Hi, my name is Patrick Reagan. Welcome to the Security, where we discuss security with a focus on how it affects the computer and the services and resources that the computer connects to. In Part 5, Wireless Security Protocols and Authentication Methods, we go over the various wireless security protocols such as WPA, WPA2, and WPA3, and discuss TKIP and AES. We also cover Radius, TACACS+, NTLM, and Kerberos. When you connect to a home wireless network or corporate network, you'll have to specify the name of the wireless network or service set identifier, also known as SSID. You also have to specify a known passkey for the network. First security attempt was Wired Equivalent Privacy, or WEP. It is not a recommended wireless security protocol. WEP was an initial attempt at wireless security and discovered security weaknesses within a few months. The recommended wireless security protocols are Wi-Fi Protected Access, or WPA, as an interim standard prior to the ratification of 802.11i standard. WPA provides strong data encryption via Temporal Key Integrity Protocol, or TKIP. Wi-Fi Protocol Access 2, or WPA2, provides enhanced data encryption via Advanced Encryption Standard, or AES, which meets the Federal Information Standard FIPS 140-2 requirement of some government agencies. Wi-Fi Protected Access 3, or WPA3, provides even more enhancements including brute force protection and public network privacy. WPA2 and WPA3, if your device is supported, are recommended over others. WPA uses TKIP and WPA2/WPA3 uses AES. Temporal Key Integrity Protocol, or TKIP, is the security protocol used in the IEEE 802.11 wireless networking standard. It was used as an interim solution to replace WEP, which includes using different encryption keys for each packet. TKIP is considered outdated and unsecure, but it can be used by older hardware. The WPA2 PSK can use both TKIP and AES-based CCMP encryption protocol used by wireless LAN products, but WPA2 Enterprise use only CCMP. Advanced Encryption Standard AES is a security protocol that was established by the U.S. National Institute of Standards and Technology, or NIST, in 2001. AES uses longer encryption keys up to 256 bits in a stronger security protocol. WPA Enterprise, WPA2 Enterprise, and WPA3 Enterprise use 802.1x to provide an authentication framework for wireless LANs. It is usually used in the corporate environments. It allows a user to be authenticated by central authorities such as a radio server. Enterprise mode uses two sets of keys, the session keys and the group keys. The session keys are unique to each client associated between an access point and a wireless client. Group keys are shared among all clients connected to the same access point. Both sets of keys are generated dynamically and are rotated to help safeguard the integrity of keys over time. The encryption keys could be supplied through certificate or smart card. Extensible Authentication Protocol, Transport Layer Security, or EAP-TLS, is the authentication protocol most commonly deployed on WPA2 and WPA3 enterprise networks to enable the use of X.509 digital certificates for authentication. EAP-TLS is needed if you want to use smart cards to store the private key associated with client-side certificates. EAP Encrypted Key Exchange, or EAP-EKE, is one of the few EAP methods that provides secure mutual authentication using short passwords and no need for public key certificates. To provide centralized authentication for remote devices that connect to switches, wireless access points, VPN servers or concentrators, and routers, you would implement Remote Authentication Dial-In User Service, or RADIUS, or Terminal Access Controller, Access Control System Plus, TACACS Plus. A RADIUS or TACACS Plus server resides on a remote system in response to queries from clients such as the VPN clients, wireless access points, routers, and switches. The server then authenticates username password combinations, determines whether users are allowed to connect to the client, and logs the connection. Remote Authentication Dial-In User Service, or RADIUS, is a network and client-server protocol that provides centralized authentication, authorization, and accounting management for computers that connect and use a network service. It can be used in wireless and remote access connection technologies, 802.1x switches, and remote desktop services gateways. RADIUS is defined in the Internet Engineering Task Force, RFCs, 2865 and 2866. It uses the UDP as a transmission protocol port. It uses UDP port number 1812 for authentication and authorization and 1813 for accounting. To simplify the management of RADIUS connections, users and/or devices can be put in groups. RADIUS clients, also referred to as access servers, are servers and devices such as wireless access points and 802.1x switches that forward RADIUS requests to a RADIUS server. An access client is a computer or device that contacts or connects to a RADIUS client, which requires authentication and authorization to connect. Terminal Access Controller Access Control System, or TACACS, refers to a family of related handling protocols for remote authentication and related services for networked access control through a centralized server. TACACS combines authentication and authorization. The original TACACS protocol, which dates back to 1984, was used for communicating with an authentication server common in older Unix networks. A user already authenticated via TACACS into the network was automatically logged into other resources in the system as well. TACACS in its original form is not very secure and has been updated and replaced by TACACS Plus, which is the proprietary form by Cisco Systems. TACACS Plus is also considered more reliable than RADIUS because it's based on TCP and uses TCP port 49. NTLM Manager, or NTLM, is a legacy suite of Microsoft security protocols that provides authentication, integrity, and confidentiality to users. NTLM is an integrated single sign-on mechanism, which is probably best recognized as part of the integrated Windows authentication for HTTP authentication. It provides maximum compatibility with different versions of Windows, and compared with Kerberos, it is the easiest to implement. NTLM uses challenge response mechanisms for authentication in which clients are able to prove their entity without sending a password to the server. After a random 8-byte challenge message is sent to the client from the server, the client uses the user's password as a key to generate a response back to the server using MD4, MD5 hashing algorithms, which is a one-way mathematical calculation, and DES encryption, a commonly used encryption algorithm that encrypts and decrypts data with the same key. If you're accessing Windows computers such as Windows 10 or older that is not part of a domain or cannot communicate with the domain controller, you are most likely using NTLM. Kerberos is a computer network authentication protocol that works on a basis of tickets to allow nodes communicating over a non-secure network to prove their entity to one another in a secure manner. Kerberos was designed primarily for a client-server model to provide mutual authentication where both the user and servers verify each other's entity. The password is never sent over the network. The client authenticates itself to the authentication server, which forwards the username to a key distribution center, or KDC. The KDC issues a ticket granting ticket, or TGT, which is a time-stamped and encrypts it using the Ticket Granting Services TGS secret key and returns the encrypted result to the user's workstation. When using Kerberos, You only have to authenticate once and can use the ticket for a period of time to access the resources. Kerberos uses UDP port 88 by default. When using Kerberos, the time of the client cannot be off more than 5 minutes. Due to the weak security implementations, Microsoft has recently announced that NTLM is being deprecated in favor of Kerberos authentication starting with Windows 11. Because of this, Microsoft is extending the Kerberos protocol to include a new public extension called IA-Kerb. It will allow clients that don't have line-of-sight access to the DC to authenticate through another server that does. Servers then will be able to proxy Kerberos requests on behalf of clients. A local KDC in Windows 11 will add Kerberos support to local accounts. The new local KDC uses AES encryption out of the box to improve the security of local authentication. Question: which of the following is the proprietary Cisco AAA protocol? Answer: TACACS+. Question: which of the following can be used with wireless devices that requires both a user and computer to be a specific group to connect to Wi-Fi? Answer: Radius. Question: what can we use to generate a login ticket to a corporate network over an insecure network connection? Answer: Kerberos. Question: you have a Soho wireless router that is about 10 years old. Which of the following would be the most secure wireless network possible that you would use? Answer: WPA2 with AES. Question: which of the following Wi-Fi protocols is the most secure? Answer: WPA3. For more information, visit these sites. In summary, AES uses longer encryption keys than TKIP, up to 256 bits, and a stronger security protocol. Therefore, AES is recommended over TKIP. WPA Enterprise, WPA2 Enterprise, and WPA3 Enterprises uses 802.1x to provide an authentication framework for wireless LANs. Extensible Authentication Protocol, or Transport Layer Security, EAP-TLS, is the authentication protocol most commonly deployed on WPA2 and WPA3 enterprise networks to enable the use of X.509 digital certificates for authentication. To provide a centralized authentication for remote devices that connects to switches, wireless access points, VPN service or concentrators, and routers, you would implement Remote Authentication Dial-in User Services, or RADIUS, and Terminal Access Controller Access Control System Plus, or TACACS Plus. NTLM Manager, or NTLM, is a legacy suite of Microsoft security protocols that provides authentication, integrity, and confidentiality to users. Kerberos is a computer network authentication protocol that works on the basis of tickets to allow nodes communicating over a non-secure network to prove their identity to one another in a secure manner. Thank you for watching this video. The next video will be Security Part 6, Threats and Vulnerabilities. If you have not already, don't forget to subscribe to the Pat Has Your Back channel. Thank you.